Hello and welcome to our show.
It's a pleasure to be here.
Before we get into our analysis today, I do need to state something clearly for everyone listening.
Of course.
This review is generated by artificial intelligence.
An important point to make up front. Absolutely. So today, we are going to examine the book Efficient Node.js, a Beyond the Basics Guide. A really interesting text. It was written by Samer Burna and published by O'Reilly Media in 2025.
And our goal for this session is to analyze the book chapter by chapter. We want to help you, the technical listener, understand how to build efficient back-end systems.
And I think the best place to start is with the preface.
Please, go ahead.
The author, Samer Burna, explains his motivation very clearly. He says that so many tutorials focus on libraries and frameworks.
Things like express.js or nets.js, I imagine.
Exactly. And while those tools are very useful, they can cause developers to skip the fundamentals.
So this book goes back to the beginning.
It focuses on the Node.js runtime itself. The core argument is that you must understand the native capabilities of Node, the base layer, before you start adding external libraries on top.
And who is this book for, exactly?
It's aimed at developers who already know JavaScript basics, but they want to, really master the backend environment.
That makes perfect sense. If you have a strong foundation, you can build much better structures. Let's begin with Chapter 1 then, Node.js Fundamentals.
Certainly. The chapter starts by defining what Node.js is.
Which is?
It's a platform built on the V8 JavaScript engine. That's the same engine used in the Chrome web browser.
Okay, so it takes JavaScript out of the browser and onto the server.
Precisely. But the most important concept it introduces is the non-blocking model.
That sounds technical. How does it work?
Well, Node uses what's called an event-driven approach. It means it can perform multiple operations at the same time. It doesn't have to wait for one task to finish before it starts the next one.
Which makes it very fast and efficient.
Very. The chapter also brings up NPM, the Node Package Manager.
A critical tool for any developer in this space.
It is. The author explains the idea of a dependency tree. When you install just one package, let's say ESLint, you aren't just getting one thing.
You're installing everything that ESLint depends on to work.
Correct. And this creates a huge tree of code, which leads to a warning from the author about security.
Because you're responsible for all that code, even if you didn't write it.
Exactly. Bad actors can exist in open source. One bad package in that huge dependency tree can compromise your entire project.
That is a very important warning. Convenience certainly comes with responsibility. So let's move on to Chapter 2, Scripts and Modules. How does Node load and run code?
This chapter gets into the details of the two different module systems inside Node.js.
Two systems.
Yes. First, there's CommonJS. That was the original default system. It uses the require function to load files.
Okay, that will be familiar to many developers.
Then there's the ES module system. This is the native system for JavaScript itself, also used in browsers. It uses import and export statements.
And the book emphasizes that you really need to understand the difference.
You do, because they behave differently. One interesting technical point it mentions is the require.main check in CommonJS.
What does that do?
It lets a file check if it's being run directly by the user or if it's being imported by another file. It's very useful for creating code that can be both a library and a standalone script.
And ES modules don't have that.
Not in the same simple way. You have to use a different method involving import.meta.url.
I see.
Finally, the chapter covers module caching. Node remembers modules it's already loaded, so it doesn't have to read them from the hard drive every single time. It saves a lot of time.
Efficiency is definitely a recurring theme. Which brings us to perhaps the most important concept in Node.js. Chapter 3, Asynchrony and Events. Can you introduce us to the event loop?
The event loop truly is the heart of Node.js. The book gives a great visual description. Imagine it as an infinite loop.
Oh, yeah?
Its job is to manage two key areas. The first is the call stack, which is where your code actually runs.
And the second?
The event queue. This is where tasks wait to be processed.
So how do they work together?
The logic is quite simple, but very powerful. The event loop constantly checks the call stack. If the stack is empty, it looks over at the event queue. If a task is waiting, it moves it to the stack to be executed. And that cycle just repeats forever.
And how do developers manage these asynchronous tasks in their code?
Well, the chapter compares three different ways. First, there are callbacks, which is the old style. The author explains they can get very complicated and messy.
Then came promises.
Correct. A promise is an object that represents a future result. It's much cleaner than a callback. But the most modern way is async await.
which makes asynchronous code look synchronous.
Exactly. It makes it so much easier to read and understand. The author really emphasizes that promise objects are far better than callbacks for control and readability.
It is interesting to see the evolution toward more human-readable code. Let's skip ahead a bit to Chapter 6, which is all about streams. This seems very relevant to efficiency.
It is. The central problem streams solve is memory usage.
How so?
Well, imagine your server needs to handle a very large file. The simple way to do it is to read the entire file into the computer's memory all at once.
But that sounds like it could cause problems.
Big problems. The author provides a specific experiment. Without using streams, a server's memory usage jumped from about 17.8 megabytes to 402.4 megabytes.
Wow, just from reading one big file.
That's right. Now imagine several users requesting that file at once. The server would run out of memory and just stop working.
So what is the solution?
The solution is streams. Streams process data in small, manageable chunks over time. They don't load the whole file at once.
Keeping memory usage low and stable.
Exactly.
The book lists 4 types: readable streams, which produce data; writable streams, which consume data; duplex, which can do both; and transform streams, which can modify data as it passes through. And is there an easy way to use them?
The author highly recommends the pipeline method. It's a function that connects streams together and, very importantly, handles all the errors automatically, which can be difficult to do by hand.
That difference in memory is shocking. It really shows why this knowledge is so vital. Let's look at Chapter 7, Child Processes. How does Node scale beyond just one process?
As we discussed, Node.js runs on a single thread. This can be a limitation. If you have a task that requires a lot of heavy calculation, it will block that single thread.
Meaning the server stops responding to other users, has to wait until the calculation is done. To solve this, the book introduces the Node.childProcess module. And what does that module allow you to do?
It lets you use a technique called forking.
Forking.
You create a copy of your main process. You can then send all the heavy work to this new child process.
And the benefit is that the main thread stays free.
Precisely. It can keep handling new requests from users, so the application remains responsive even while doing difficult work in the background.
So you create a copy to do the heavy lifting. A very clever solution. Moving to Chapter 8, the topic is testing Node. Why is testing so important?
The author takes a very strong position here. The book states, untested code is simply dangerous.
That's a powerful statement. It is. The goal of testing is simple: to prove that your code does exactly what you think it does. It's a guarantee of quality. And what techniques does it suggest?
One key technique is using test doubles. These are basically fake objects like mocks or stubs. You use them to isolate parts of your code during a test.
So you can test one function without needing a whole database or network connection to be working.
Correct. And it also covers continuous integration, or CI.
An automated system.
Yes, a system that runs all your tests automatically every time the code changes. If a test fails, the change is blocked. It's a critical practice for keeping code reliable.
Untested code is simply dangerous. I think that's a takeaway everyone should remember. Let's finish with Chapter 9, Scaling Node. How do we handle more traffic?
The author makes the point that scalability is, in a way, baked into Node.js. It's part of the original design.
And what are the strategies for it?
The book lists 3. First is cloning, which means running multiple copies of your application. Second is decomposing, breaking the app into smaller microservices. And third is splitting the data, which is often called sharding.
Which one does the chapter focus on?
It focuses heavily on cloning, using the built-in cluster module.
And how does that work?
It lets a primary process fork worker processes, usually one for each CPU core on the server, and the author provides another load test to show the impact.
And the results.
A single process handled about 16 requests per second. The cluster, using the same hardware, handled 123 requests per second.
That is a 7-fold increase in performance.
It is. And what's more, the cluster module enables something called zero downtime restarts.
Meaning you can update the server without it ever going offline.
That's right. You restart the worker processes one by one. While one is restarting, the others are still working, so users never experience an interruption.
A 7-fold increase is truly impressive, especially using the same hardware. We've covered a lot of ground. From the V8 engine and the event loop, to memory efficiency with streams and scaling with clusters.
It's been a comprehensive overview.
I think the main takeaway from all of this is very clear. Understanding the low-level runtime makes you a better, more effective developer.
It lets you write faster code, use less memory, and ultimately handle more users.
So if you found this discussion interesting, I would explicitly recommend that you read the book Efficient Node.js by Semer Buna. The book itself contains all the full code examples, diagrams, and deeper explanations that we just couldn't cover in our time here.
I completely agree. The examples are very practical. It's a truly valuable resource for anyone who takes back-end development seriously.
Thank you to our friends of the show for listening. We encourage you to subscribe for more technical analyses like this one. We wish you a great day.